Hey there, thanks for joining me today. This is Luigi from mlmproduction.com, and I'm coming to you with a tutorial on Amazon SageMaker. SageMaker has gotten a lot of news in the press over the last year, and it's definitely gained a lot of popularity, but there's relatively little content out there showing data scientists and machine learning engineers how to use SageMaker, how to train models, how to deploy models to production for inference, and it's not very complicated, but there's a lot of moving pieces. So I think it deserves a good explanation. This tutorial is based on a talk I gave a couple of weeks ago at Insight Data Science. And while there, I showed the AI fellows how to build, train, and deploy custom machine learning models using Amazon SageMaker. So in this tutorial, I'll walk you through how to create a notebook instance, how to build a Docker image that's compatible with SageMaker, and train a custom scikit-learn model in that container. We'll cover inference in another video, and in order to access the notes for this tutorial, please click on the link in the description below. So the first step of the tutorial is going to be to create a notebook instance on Amazon SageMaker. And the notebook instance is going to allow us to use the Jupyter Notebook to access SageMaker and to run our code. And in order to create the notebook instance, we can just follow the directions. In step 2, create an Amazon SageMaker notebook instance of the SageMaker documentation. I'll provide a note. I'll provide a link to this in the notes of this tutorial. So just following along here, the first step will be to open the SageMaker console. And log in with your credentials. If you don't have credentials, you're going to have to create an AWS account. And once you log in, this takes you to the home page, the dashboard of Amazon SageMaker. And we're going to get to all these different links at various points of the tutorial, but we're going to just start by creating a notebook instance. So to do that, you just go to Notebook Instances here. And notice that I have no notebook instances running right now. Once you create a notebook instance, it'll be displayed here along with its name and additional metadata. And you'll also be allowed to stop the instance, delete the instance, create new instances, etc. So the next step is to just create a notebook instance by clicking on this button right here. And we can provide a notebook instance name. So I will call this ML in production. And I'll append today's date, July 20th. We can use the default notebook instance type here, which is a T2 medium. Next, we have to create an IAM role for the notebook instance. If you're unfamiliar with IAM, it's Amazon's security-based system which gives users privileges to access different AWS services. So before we create one, we'll be creating a new one for the tutorial. I'd just like to show you that how creating one will impact the rest of the IAM instances. So we can open up the IAM service in another tab. And if we go to roles, notice that I just have 2 roles here. And in fact, these are just the default roles that are created when I created my AWS account. So let's go back to the SageMaker tab. And let's create a new role. And let's set the S3 buckets you specify to none. And the default permissions that are set here are going to be set so that our notebook instance has access to a bunch of S3 buckets that we create. For example, if SageMaker appears in the name of any S3 bucket, our notebook instance will automatically have access to it. If there's any object on S3 with SageMaker in the name, our notebook instance will have access to it, and a few more permissions here. So we can create that role. And notice here it's a success. We created this role. And if we scroll back over to the IAM Management Console and we refresh the page, you'll notice that that new role has been created and is automatically here, and it's given permissions over to SageMaker. So that's what we want to see. And those are basically the only configuration we need to set up at this stage. So let's create the notebook instance. And notice here it says success, your notebook instance is being created. And the name of the notebook instance is the name we gave it, which is ML production, appended with today's date. It's a T2 medium type instance. We just created it now, and the status is pending. And what's happening behind the scenes right now is that AWS is spawning an EC2 instance and installing all the necessary dependencies that are necessary, as well as launching the Jupyter Notebook. So once the Jupyter Notebook service is ready, we'll be able to very easily log into it and have a Jupyter Notebook instance running. So we'll just give that some time and wait for the instance to finish initializing. So the notebook instance is now running, and it says here that it's in service. It only took a couple of minutes, and we can now open our Jupyter Notebook instance very easily by just clicking Open Jupyter here. Notice it takes us directly to a Jupyter Notebook in the browser, and the name of our notebook instance is prepended to the URL here. And since we're running one of the examples provided in the documentation, Amazon's made it very easy for us by creating another tab with all the examples. So what we'll do is go to this tab and directly be able to copy all of the files associated with the tutorial into our directory and be able to use them directly that way. So let's go to the SageMaker examples tab here. And there's a bunch of tutorials that they provide. This is great documentation and a great set of examples for you to go through. But the example we'll be going through today discusses specifically how to create our own scikit-learn classifiers using the scikit-learn library. So we'll minimize this tab here. And our example is in the advanced functionality dropdown. Let's drop that down and scroll down to where it says scikit-learn bring your own .ipython notebook. And we'll click use. We can specify the name of the directory, and this also lists the name of all of the files that we copied over into our local notebook instance. So let's create copy. Let's click create copy. And what happens when you click create copy is that it brings you directly into the Jupyter Notebook that contains all of the code we'll be using for the tutorial. But I'd just like to show you the set of files that have been copied over. So we click back onto Files tab. Notice there's a new directory called scikit bring your own 2019-720. If we click into it, you'll see the IPython, the Jupyter Notebook file that we have open, as specified by the little green icon here, as well as a directory structure, as well as two additional directories and an image file. The container directory contains files we'll be using throughout the tutorial, and the data directory contains the actual data set that we'll be using in our example. And in this example, we'll be using the familiar iris data set. Now that we have the notebook file open, we can start working on building our Docker images, looking at the Python code that's going to be responsible for training and inference, as well as reading all this documentation here. So the notebook file is really well put together and includes a lot of documentation and a lot of explanation. So I highly recommend that you take a look at it, read through it. It does a really good job of answering a lot of questions you may have. And if you have any additional questions or need any additional clarification, definitely leave some comments on this video, and I'll definitely get back to you and answer those questions. So I'm going to take you through what I consider to be the more important parts of the notebook. I'm not going to spend my time reading through the documentation. I'll leave that up to you, but I'll just do as good of a job as I can explaining the code that we're going to run. So the notebook is introduced with a lot of documentation. And the first part of the notebook that's really important is about Docker. And as I explained in my last blog post where I introduced the SageMaker architecture, SageMaker heavily relies on Docker. And the amount of Docker that you have to know is really based on the level of features that you want to use within SageMaker. So if you want to use the pre-built SageMaker algorithms, you don't really have to interface with Docker very much. But if you want to build your own custom solution, your own custom algorithm, like we're going to do in this example, you have to be quite familiar with Docker. You need to be able to create images. You need to be able to push these images to Amazon ECR, which is its container registry service. So we'll start by taking a look at the Docker file, walking through it, and showing how to build the Docker image and how to push this image over to EC2. So if we scroll down, this part of the notebook here shows the directory structure, right? So there's a Docker file, there's another file called shell scripts called build and push, and then there's a directory, a subdirectory called decision trees, which contains another set of files. Two of these files are responsible for serving our Docker image, serving our algorithm, and training our algorithm. And the rest of these files are all really responsible for setting up the web server. And we'll get to those in our next video on actual inference, but for this video we'll be focusing specifically on training. So we're going to have to look first at the Docker file. And the first actual executable cell here allows us to spit out the contents of the Docker file. I don't think it's very easy to read here, so I just prefer to go back to the homepage of the notebook instance and click specifically on the Docker file, and this will just open up the file in a text editor. And let's walk through this Docker file and see what it's doing. So we're starting from the base Ubuntu Docker image, version 16.04. We're setting up some metadata here. This is just specifying that this Docker image is maintained by Amazon AI. And the first thing we're doing is installing a set of system dependencies using apt-get. So we're installing wget, we're installing Python, we're installing nginx. This will be used during inference, as well as a few other things. In the very next command, we're installing pip, which doesn't come pre-installed on this Ubuntu image, I'm guessing. We're then running the file that actually installs pip. So we're first downloading the file to install pip, and then we're running that file that installs pip. Once pip is installed, we're pip installing a number of Python dependencies. So version 1.16.2 NumPy, SciPy, scikit-learn, pandas, Flask, gevent, unicorn, and setting up some, what looks like, deleting some random files here, deleting cache files. Again, this is explained in the comments here. Next, we set a bunch of environment variables, and these environment variables are explained in the comments here. And then we're copying the decision trees directory from the host to /opt/program within the Docker image. And then we're setting /opt/program as the working directory of the image. So if we scroll back over to our notebook, this is the same exact file we saw. The next cell shows us how to build the image and how to push the image to ECR, which is Amazon's container registry service. So in order for SageMaker to be able to access the image when we train an algorithm or when we run inference, the Docker image needs to be available to SageMaker. And in order to make this happen, we first build the image locally, and it could be on the notebook interface or it could be on our host machine on some other machine we're using. But in this case, we're going to be building the image on the notebook instance, which is already on EC2. And then we're going to be providing some metadata, and then we're going to push that image to ECR. So again, this is the contents of another file that's within this directory, and that file is called build and push.sh. So let's look at that file in the text editor. And let's just walk through it. So this is a shell script. It accepts the name of the that we want to give this image from the command line. It then sets two files to be executable. In this case, decision trees/train and decision trees/serve. And these are the files that are going to be responsible for training the algorithm and serving the algorithm, and we'll walk through those later on. It then performs a number of AWS commands, specifically in order to get this full name variable, which is going to be the location of our Docker image. Right? So in order to push our Docker image to ECR, we need to tag it with some name, and we're just working to, this code here is just working to create this name. So we first get an account number using this command. We then get the region that we want to use, and we then create this variable full name, right? We then check to see if this repository exists. If it doesn't exist, we create it. We then log in to the command line client using AWS ECR get login. We then build the Docker image with the docker build command, specifying the name that we passed in to the shell script. We tag the image that we built with the location of the ECR repository that we specified up here in full name, and we then push this image to ECR. All right, so basically from top to bottom, we're setting some file permissions. We're programmatically creating the name of the ECR repo that we want to push our image to. And then we build the image, tag the image with that name, and push the image to that location. So in order to run this, let's go back to our notebook. And this cell contains the code of that file, but just defaults the name to SageMaker decision trees. So rather than run this cell here, which you could do, I'm just going to prefer to run the actual shell script, but I'll use the same algorithm name that we're going to specify here. And we can go back over to the home page here, and we can create a terminal window. And by default, we're going to have to change directory into SageMaker, scikit-learn, container. And now that we're here, we can see that we have the build and push.shell script available to us. And before I run that script, I'd just like to show that there are no Docker images currently installed on this machine. And if we open up ECR, this is the ECR service. I have no repositories currently on ECR. Right, and I just like to show that we're going to have a repository after running that script. So let's go back over to our terminal window, and let's run the shell script and provide the name SageMaker decision tree. So that's going to be the name of our image. So let's just run that. Right, so we are building the Docker image right now. It's running each step in the Docker file. And once this is complete, we're going to tag the image with the specific ECR name, and we're going to push that image over to ECR. So since this is the first time that the image is building, it takes a little bit longer because it's installing all the packages, and it'll probably take a little bit. It'll probably be a little bit faster later on, since it'll be using cached versions of the container unless we specify otherwise. So it's completing the Python installs right now, and if you notice, it tagged the image with the programmatically created location on ECR, and now it's pushing that image over to ECR. Great, and that's complete. So now we can look at the images that are on the machine with the Docker images command. And notice there is these, so there's the Ubuntu 16.04, which is the base image. There's the SageMaker decision trees image which we created locally, and then it's a new tag specifying the location on ECR. And if we navigate to ECR and refresh the page here, notice that we now have a new image on ECR called SageMaker decision trees. So before we run the model training process on SageMaker, we're going to run it locally on the notebook instance just to test it out, debug it, and understand what's going on. So to do that, let's first take a look at the actual training script, understand it, see what it does. To do that, I will close out this tab, close out the Docker file, this build and push script because we're done with it, and this terminal for the time being. And I'll go to the decision trees directory, and I'll open up train. So train is a Python script that's responsible for training a scikit-learn model. So let's have a look at it, and let's just walk through it line by line and see what happens. So we first import some necessary libraries, some Python libraries, pandas, and we import the tree class from scikit-learn, for the tree module from scikit-learn. We then set up a number of local variables here. One is called prefix, and it's obviously a path, opt, /ml. And then we have a number of other paths here. We append input data to the prefix. We append output to the prefix, model to the prefix, and input config hyperparameters.json to the prefix. And the reason why we do this is because SageMaker expects to store certain model artifacts, certain training artifacts in certain locations. So for instance, after we train the model, we're going to want to serialize the model. And SageMaker expects that model to be serialized in a certain location so that it can then go ahead and retrieve those model files and store them on S3 for us. And similarly, it expects to store certain output and the hyperparameters for the configuration in certain locations. And if we want to actually have a look at what those locations are, we can go back over to the notebook, scroll up, and have a breakdown of what is expected where right here. Right, so this breaks down where the training data is to be located, where the configuration for the training process is to be located, as well as where the output from the training job should be stored. So /opt.ml model, /opt.ml output, etc. So let's go back over to the training script. We then define a function called train. And train is responsible for training the algorithm. And we then just call that train function. That's basically the only function. That's the only function that's defined here, and it's the only function that's going to be run when this script is run. So let's walk through train. We open the file containing the hyperparameters, right? And this file is specified in one of those local variables in the global namespace. We then read in the files using, we read in the training data using pandas.readcsv here. And if there are multiple files, we concatenate these together. We then specify the NumPy arrays for the training data X and for the target label Y. We retrieve some hyperparameters from the training params dictionary that we get by loading in the config to the training process. And then we train a decision tree classifier. We instantiate the classifier here, and then we train the classifier in the very next line. Once the model is trained, we then store this model in the path that SageMaker expects the model to be stored, and we call it decision-tree-model.pkl, and we pickle the model. And if there's any error, we print out the stack trace and exit the process. So the training file is actually very, very simple. All we're essentially doing is reading in a data file, reading in some hyperparameters, fitting a classifier from scikit-learn, and then storing the classifier as well as the output in the paths that SageMaker expects us to store these files. Right. So before we run model training using the Python SDK in SageMaker, we'll run training locally in the notebook instance, and then we'll also run inference locally just for debugging purposes. The example contains the code necessary to run training and inference locally, and the directions for doing that are in the very next cell in the notebook. Basically, there is a subdirectory within the container directory called local test, and local test contains a number of shell scripts as well as a file containing some tested data. So the train_local shell script is responsible for running model training locally. Let's have a look at that. It's a really simple script. Basically accepts a Docker image name as its only argument. It then creates two directories, testdir/model and testdir/output. And the -p flag just means not to raise an error in case these directories already exist. We then delete anything that's contained within these directories in case we want to run the script multiple times. And we then have the command for running a Docker container. Right? So Docker run creates a container from a specific image that we're specifying at the command line. It attaches a volume to that image, so anything that's available from the testdir directory locally will be available in the container at opt_ml, and similarly anything that's stored in opt_ml, like the serialized model, will be available locally at this testdir directory. And then we run the train Python script. Right, so in order to run this file, let's create a terminal. And let's change directories into that directory. And notice we can go into testdir here. And let's just delete the model subdirectory and the output subdirectory, since our script will recreate these. We need the Docker image name. We need to pass that to the train local script. And now let's run training. Passing in the image name. And notice that we printed the starting the training and training complete lines. And these lines are from the actual train script. So if we scroll back over to that script, you'll see that starting the training is printed when training is called, and then training complete is printed when the model training and model serialization successfully occurs. Now that the model is trained, we can run inference. In order to look at the script that does that, let's go back over to the directory and let's have a look at serve_local.sh. This script is pretty simple. It accepts an image name, and then it runs another container from that image. And it attaches the same port from the training script, and it also exposes port 8080. And the reason it does this is because the serve script launches a web server that accepts incoming connections with data, performs inference, and then returns the data to the user. I'm not going to look specifically at the serve Python script in this tutorial because we're going to cover inference next time, but we will run the script. So in order to run the script, let's create another terminal. And let's change into that directory. Let's get the image name, SageMaker decision trees. And let's run the serve local script, passing in that image name. So notice that we have some log output, and this is from the web server. And now we want to open another terminal window and use curl to make some requests to this running container. All right, so if we scroll back over, create another terminal. Let's change into that directory again. Oops. We have the predict.shell script. Let's take a look at it here. Predict.shell just runs curl, passing in the contents of whatever file that we pass in as the first command line argument. All right, so if we actually scroll back to our notebook, you see that there's an example command here for running inference. So let's just copy that. And let's run predict.shell, passing in the payload CSV file in the text.csv format. Let's see what happens. Okay, so we did get the request did return a response, but there was an error response. And the first time I took a look at this, I was not quite sure what was happening, but it turns out that there's actually an error in the serve script. Basically, the serve script expects a column expects a first column that contains the label. I'm sure this was an error when they created this tutorial, but that first column is ignored, and prediction runs using just the input data. So in order for us to actually run run inference, what I'm going to do is edit that file to edit the payload.csv file. We could just take a look at here. This contains the data. I'm going to edit this and just add another column in the first column's position with null values, right? So one simple way of doing that is with the awk command. Basically, the command is awk-v, and I'll fill in this column with nulls. And in order to do this, I'll print that label that I just created, as well as the rest of that file, right? And we'll pass in payload.csv. So let's just take a look at what this will look like. If we do that, we'll see that it's the same data file with nulls in the first column. And let's just create another file with this new data. Let's call it payload fixed.csv. So if we head payload fixed.csv, we'll see that we have this new null column in the beginning, and we can rerun our inference, and this time pass in payload fixed.csv. Oops. And notice now it worked. So this is called curl, and it returns the labels of our data, which are the predictions. All right, and if we go back over to our terminal with the web server running, we can see that our first request returned an error because the number of features of the model must match the input, and our model expects 4 features, and the number of features we passed in is 3. But our second request returned HTTP status 200, which means it was successful. So that is training and inference locally on the notebook instance. but now we can navigate back over to the notebook and actually use SageMaker to run model training. So let's just summarize what we've done up until this point. We started by creating our notebook instance on SageMaker. What this did was spawn a new EC2 instance and start the Jupyter service on that instance. We then copied the example directory onto our local notebook instance. And then we took a look at the Docker file that basically built up our image that we use for model training and model inference. And we performed model training and model inference locally. But the whole point of using SageMaker is so we can take advantage of basically the infinite compute on the cloud, right? And we don't want to be running model training and model inference locally. We'd like model training and inference to scale based on the number of resources we need. So we're now going to perform model training with these advantages, being able to scale up with the number of machines that we need. In order to do that, we'll actually execute some code in the Jupyter Notebook that allows us to use the SageMaker Python SDK. So this part of the notebook is about performing model training, but not locally in the notebook instance. Instead, we're going to use the notebook instance to make certain API calls that are going to perform training on SageMaker and are going to serialize and store the model as well as other outputs on S3. So let's start going through these cells one by one. So rather than store our artifacts locally, these artifacts are going to be stored on S3. So the prefix that we're going to use here for our S3 bucket is going to be demo scikit byo iris. And we can really call this anything, but let's just use this as is. So what this cell does is import some libraries and then get the role associated, our AWS IAM role that we created earlier. So let's just run that. We can take a look at the role here. And this is that same role that we created earlier on. We'll now create a SageMaker session. And this session is responsible for holding all of our metadata for our connection to SageMaker. And now we need to start interacting with S3. And basically how SageMaker works is that it relies on S3 as its storage system, right? So we want to put our training data on S3 so that when SageMaker creates EC2 instances for training, those EC2 instances can point and pull data from those S3 buckets that contain the training data. Then once training is complete, the EC2 instances can move the trained model objects back to S3. So essentially this is like we're using S3 as a distributed file store, and SageMaker is handling the moving of data back and forth from S3 to and from the EC2 instances that are doing model training and model inference. So what this cell does here is move our training data over from our local machine to S3, right? And it's going to create an S3 bucket and store the data there. So before we run the cell, let's open up S3 and see what running this cell does for us. So I only have one bucket here, and this bucket is called ML in production. If we go back over to the notebook and run this cell, it completed, it returned. And if we go back over to S3, we now have this new bucket, right? It's called SageMaker -US-east-2 followed by a number. If we open it up, we see that there is a directory here with that prefix that we gave it, demo scikit byo iris. If we go in there, there's that iris.csv file, right? And that iris.csv file is the training data that's available locally in the container, in decision trees, in data. right? So with that single command, in that one single command, SageMaker took care of creating an S3 bucket and moving our data from our local machine over to S3. Right. So all that's left to do is actually to perform model training. Right. And again, it's just a simple set of API calls in this case. But what's going on behind the hood is really important to understand. Right. So let's first take a look at this code, and then we'll walk through what's actually happening. So the first couple of lines just get some metadata for us. So in order to see what's going on, I'll split this into multiple cells. And we'll run this cell and just print out what these variables actually are. Right? So account is account number, region is US East 2, and the image is just the URL of the image on ECR. Right? So this is all metadata that needs to be passed to the actual SageMaker code in order to perform training. Right? So now the code that actually performs training has an API that's really similar to the scikit-learn API. So if you're familiar with that API, this one shouldn't be too disarming, but it does contain some additional parameters that we should talk about. So let's just walk through these variables one by one. So the class that we're going to use is the sage.estimator.estimator class, right? And this class is responsible for training an estimator. And let's look at the arguments that we pass to it. Well, let's actually look at the documentation. It might make our lives easier. So the first parameter that we pass is the image name. And this, again, has to be an image that's available to us. In this case, I'm feeding the image URL from ECR. The next is the IAM role that we created earlier. And the next is the number of EC2 instances that we want to use for training. All right, so in this case, we're just going to use one instance for training. The next parameter is the type of instance used for training. In this case, we're going to use a C4 2XL. You could use a smaller image if you'd like. And then the next line is the output path, meaning where we'd like to store the outputs of the training process. Notice that we can just provide, we can call the default bucket from our SageMaker session that we started earlier. And in fact, let's actually call that so we could see the output. Right? And this is the bucket that we see here, and that's the very same bucket that we created in our earlier call, and it's this one right here. Right? And finally, we pass in the session, which contains the rest of the metadata. Once we create that class, we actually just call the fit method, passing in the location of our training data. Right? So just so we can see it one more time, data location is just this S3 path. So when we run this cell, this class is going to take charge of ensuring that SageMaker creates EC2 instances, that it runs the appropriate files, that it retrieves the training data from S3, runs model training, and then persists the artifacts of the training process back to S3. So we can actually monitor all of the resources that get created by taking a look at our SageMaker dashboard. So if we scroll over to that and we go to training jobs, what we'll see here are training jobs that I ran a little bit ago, about a month ago. So we could ignore these for the time being, and we can call fit and see what happens. So things we should expect. We should expect to see a new training job here, and we should also expect to see a serialized model stored on S3. All right, so let's call this cell. And we're going to have some log output from this cell telling us what's happening. So it says here that it's starting job, and if we scroll back over to our dashboard, we can see whether or not this job has been logged yet. And notice that it has. We have a SageMaker decision trees job with today's date. The creation time is today's date, and this job is currently in progress. If you go back over to the notebook, the next log output says that it's launching the requested ML instances. Right, so SageMaker is now doing the appropriate work to create the one ml.c4.2xl large instances, right? These EC2 instances, and it's then going to pull the Docker image that we specified when we passed in image. It's going to run a container from that image, and the command that's going to run in the container is the train command. And after the model training completes, SageMaker is going to ensure that the outputs from the training process are persisted back to S3. So we should be able to scroll over to S3 when the job completes, and we should see the stored model object. So this may take a few minutes to actually do all of this work. So we could talk about a few more things. What's really excellent about this, all of this stuff is, first of all, we don't need to write this code, this boilerplate that performs all of these actions. SageMaker takes care of all of these things for us. And another thing that's really great is that SageMaker will automatically shut down the EC2 instances once model training completes, or if we get an error, right? So this is really critical for us, because if we're looking to run a lot of training jobs, we don't want to accidentally leave the EC2 instances running once training complete, right? That would cost a lot of money, especially if we're using more expensive instance types. For instance, if we're using GPUs, they can get really expensive really quickly. So what SageMaker does behind the scenes is launch the EC2 instances, run the training, store the results, and then shut the EC2 instances down, so we don't need to worry about burning a hole in our budget with AWS. So we have some more log output. So it's preparing the instances for training. It's downloading the input data, downloading the training data. All right, so now we see the log output from the actual training jobs. So that's a good sign. So that means that the train script is called, and uploading generated training model, and it's completed. So this whole process took about, so we're going to get billed for 46 total seconds, which is pretty excellent. So we even get to see how much we're going to be spending. So if we go back over to our dashboard and refresh the page, we'll see that the job is complete. And if we go over to S3 and refresh the page, we'll see that we have this output directory, and the output directory has our model, right? And our model has been compressed and stored here. So our training job is complete, and SageMaker took care of storing our persisted model on S3. Right, so this is a really exciting, a really cool tool. And if we look back over our notebook one last time, you can see that it really didn't take much code for us to do this, right? Aside from training, aside from building the Docker image and pushing it to ECR, there's very little actual Python code we had to write in order to do all of this complex work, right? This was basically just getting metadata, and there was really just two classes. There's really just one class and one method that we called.